Go. Go.
Hi, this is Grandpa or Grampy, depending upon what his name is called, and I'm here to give you some background in math skills. We're going to start off with the traditional one. Name this number, please, and I shall supply the answers. This is called 4. The name of this system is floating point decimal. Okay, what number was this one? Obviously, it's still 4. Now, the next number after 4 is 5. 5 is the thumb. Now, we proceed to the earliest known form of combining numbers, which is called adding. 5 plus 4 is 9. Therefore, with a simple manipulation, you can count from 1, 2, 3, 4, 5, 6, 8, 9. My fingers don't move so well because that's my bad hand. Now we shall demonstrate the second part of the decimal point. Move over one place. That's how it moves. This is now 10, 20, 30, 40, 50, 60, 70, 80, 90. And combined with the other hand, we have 99. So with that floating point system, it can count up to 99. Therefore, you are able to do all your multiplication tables with your two hands using this system. I need a timer to look at because I'm allowed 3 minutes. However, my age is 70, 50, 60, 79. And Grandma's age is 78. But that's the end of the demo for that. Second part, if you look at the 99, you can do the subtraction. Very simply, it is the fingers that are down. If you go back to Grandpa's age of 79, you automatically know this is 10, 20. So it's 20. 99 minus 79 is 20. Or if you transpose this 99 to a dollar, $1, you would have to add 1 to the fingers that are down. Demonstration. If we put up 54, the fingers that are down are 45 plus 1 is 46. That is the end of that demonstration. Today, Lucas walks in the door. Grandpa asks, "What topic are you on?" He happens to be in the topic of geometry, otherwise known as acorns. That we will fill in later because sometimes I've told things about acorns. Anyway, geometry is the subject that came from acorns. This was the lesson plan for that demonstration. He was studying the Pythagorean theorem. Pythagorean theorem is the outlines are basically here, number forms. It doesn't have much of a picture. It was there, but got erased. Anyway, the theory is a squared plus b squared equals c squared. Or the converse, c squared minus a squared equals b squared. And then we did the whole number application. The first whole numbers that do that pattern are 3, 4, 5. The square numbers are 9, 16, 25.
30 seconds.
Okay, that is just told to move on. This is all part of that pattern. The second part is the radical sign. The radical sign was one of the greatest inventions in the history of all mathematics. Because you had to go by count, radical 1 is 1, radical 2 is 1.414. We didn't go into that part. So now I'm getting near the end of the speech. Radicals can be explored in the context of the Pythagorean theorem. And with that, I shall say goodbye.